Jelikož, dámy a pánové, dobrý podvečer, jsme na vaší konferenci poprvé, dovolte, abychom se představili. Jsme kolegové Jirky Bláhy a Jakuba Novotného z Telče, vlastně z Akademie věd, a Tomáš Zadražil, geodet, Slávek Buzek, technik vlastně AutoCADu, André Loits je kolega z Belgie, původně z Bruselu, který se zabývá už asi 16 let různými teoriemi vyměřování zakládaných měst. Moje jméno je Tomáš Drdácký, jsem architekt. A my v rámci výzkumného projektu Ministerstva kultury NAKY 2 pod vedením Fakulty architektury ČVUT se zabýváme vlastně urbanismem, vztahem historických jader měst ke svému okolí, prostorovými vazbami, a v rámci jako takového podkapitulu tady toho tématu jsme vlastně studovali dochovanou půdorysnou osnovu našich památkových měst, především vybraných památkových rezervací, a vlastně popisujeme, nebo snažili jsme se popsat ty dochované geometrické vztahy s tím, že jsme si vědomi toho, že ta otázka té vlastně stability nebo původnosti toho konceptu je velmi závislá na archeologických nálezech a na dalším studiu. Please, André.
Yes, good evening. Thank you. I apologize, I will speak in English, but I cannot check. Okay. As you heard, we are a totally atypical team because we are engineers, we are specialists in computer design, we are land surveyors and so on, but I come here just to ask the help of archaeologists and people knowing about history of the Czech cities. Our study concerns cities founded between the 12th century and the 14th century. So like, Český Krumlov, Pilsen, Minikov. And we try to understand the way they were planned in the Middle Ages. So I start with two characteristics. Some evidence, they are surrounded by walls, yes, everybody knows that, but the walls are a limit, and a very important limit between the inside and the outside of the city, between the rights of the citizens inside the city and the people outside of the city. Second limits are given by the alignments of marketplace and street. They are clearly marked in landscape. So these alignments are also very important because the limit between the public space and the private space, what is allowed behind the facade and what is allowed in front of the facade. So they have a legal role, an important legal role, and this is not. So sometimes we believe that alignments were set in a random way. But no, they were fixed from the beginning of the city. We would like to show that in cities, complex cities like Český Krumlov, we know that they were planned, of course they were planned, but the plan follow strict geometrical rules. That's what we would like to show. It's not evident when you see the map of Kadan, it seemed from Český Krumlov, it seemed totally random, totally organic, without any form. But if we look to Kadan, and if we look to the plan of Kadan, we look to the walls, we see that we can find straight segments in the alignment of the walls. And this is for us very interesting. So I spot out the straight segments. Now I measure the deviation angles from one segment to another. and on digital maps. We measured 13 angles, and we see that 2 angles correspond to 7.5 degree, 4 angles or multiples of 7.5 degree, you see? 3 angles or multiples of 7.5 degree plus 1/2, and 4 or multiples of 7.5 degree plus 1/4 or 3/4. So I show the full unit angles, half unit, and a fourth. So we mean that the wall was angulated, that the angles of deviation followed recurrent values, that we may consider the angle of 7.5 degree as an unit is the division of 90 degree by 12. Yes, it's mathematical, but yes, it may be strange. I continue. And we mean that the angles of 1/2, 1/4, 3/4 are subunits of 7.5 degree. So we say the angle of 7.5 degree is a rule. And it's confirmed when we measure the angles of deviation of the marketplace alignments. Also 7.5 degree or multiples of 7.5 degree, and they follow the same orientations as the wall. So the angle unit of 7.5 degrees is a rule for us. We verified this type of rule of more than 50 cities in Czech Republic, in Slovakia and Austria, and we think, we mean that it works, that it's right. But so to consider the angle of 7.5 degrees as a rule is the basic hypothesis of our theory. The basic hypothesis. The use of topographic angles, of course, suggests triangulation, like land surveyors do today. Triangulation is a very old science, was well mastered by Ptolemy in the 2nd century. He resolved fantastic trigonometric theorems. Myself, I have difficulties to understand them. But actually, it's based on very simple rules. The properties of a right-angle triangle. It says if we know the length of one side, we can calculate, and the value of one angle, we can calculate the 2 other sides. And each triangle, whatever it is, can be divided into 2 right-angled triangles. This is still in use today by the land surveyors with 2 rules. But of course, the land surveyors today uses devices totally out of scope in the Middle Ages. What we know about the Roman, the agrimensores, used the gomma. You can only make angles from 90 degrees or 45 degrees. Not interesting. We know also that levatores, military surveyors, use the diopter. So you can measure angles of 1 degree, but we do absolutely know how they use it, why they use it, what for. We have no description of the work of levatores. We know that they exist and that they work with a diopter. In the Middle Ages, nothing. No remains of any device, no remains of any text. But it's not a reason to think that there was nothing. So we imagine, like shaded, we imagine triangulation in the Middle Ages based on a modified Roman gomma that enable to make precise sightings, but only on angle multiples of 7.5 degrees. We built several prototypes with, I must say, excellent results. but the rule of only angles of 700 degrees. If we use that rule, we will now try to make a digital simulation of a potential triangulation of the city. See how it works. Back to Kadan. To make a triangulation, we must start from a central point, the station. We found out that the station was probably set at the place where now the tower of the town hall is built. I don't say that I use that tower. No. The tower was most probably built on the place where the station was. Now, from the station, now we measure a base. In Kadan, we could see that the base was 48 prut. It's no unit of length. A prut is 16 feet. Exactly. Now, once we have the station, the base and one pole, we start a simulation of a triangulation. Now it's the computer that will say me where are the exact sightings multiples of 700 degrees. I start. There are three possibilities. Okay, the middle follows clearly the wall. I start to make a triangle. It's not a good result. It's not a good result. So we retry. Don't worry. We retry. This time, you see the sightings simulated by the arrows cross on the wall. So this is my second pole. From there, I make sightings to the north, and I see that I can follow the wall at a certain distance, and then I cross again the wall from the station, make a new sighting, and tip top on the wall. Now I go that direction to the corner of the city, of the wall, make a sighting from there. This is the computer. Now I continue. See, the arrows stay on the wall. Now it seems that's not really successful, but the next one, once again, I do not choose. I can choose which direction, which orientation I take, but not the precise position. And you see that after a number of sides, I am back on the wall. Go to the corner. Ah, big surprise, I'm just on the corner. From there, last sighting, and I turn the buckle. Now I have a web of triangles that I can calculate. Now, next question is, why should we triangulate a city? Well, we have here a web of triangles, but not precisely on the wall, but very close to. Well, if we can triangulate a triangle, we can calculate the perimeter of the site, so we can evaluate the cost of the future walls, we can calculate the surface, and we can evaluate the income of the future city. Maybe these are interesting dates for somebody who wants, the authority who wants to found a new city. But I don't know. I don't know if they calculate. I just say they were possible to do it. They had the capacity to do it. I can show them they made calculation in the Middle Ages. It's very simple, even with complex numbers. So, and by the way, we use only 12 angles. With 12 angles, we can only create 6 different right angle triangles. So the number of the trigonometric values we need to know is very narrow. I don't say that I did it, I just say that we're able to do it. Now we continue. Next step for the surveyor so far that exists is to bring now the wall on the best position, defense position, on the edge of the hill. Kadan was built on a hill, and we try to bring the wall on the edge. So we cover our first sighting. From there, I can follow. And from here, you see, we can no more use sightings of a whole of unit, we must use half of unit. And this is the origin of half of unit. But in this case, there are no calculation more needed. So I continue that side, I use half unit, and if I continue with half unit, I have an excellent result. And there I reach the corner, just on the corner. From there, now the sighting must be a fourth of unit. It's a fourth of unit. Yes, look. I blow up. This is the position of the wall. And we are still, after 3 sightings, we are still on the wall. And if I show a full unit sighting, I'm there. Not right. And sorry, half unit, not right. I continue. Now I'm the correct position of the wall. Now, next step. We must define the position of the alignment. Well, now I apply a rule that we discovered. We make sightings from some of the poles we fixed now. I do not bust on more the position of the pole, huh? They are not fixed. I just decide from the position of the station, decide of the length and the orientation of the base, and all the rest is given by the computer. Okay. I have the west side of the marketplace. Oh, sorry. I have the east side. Now I make a siding from 4. I have the north corner, but just make a siding there. I'm just on the alignment of the street, not exactly the alignment of the marketplace, the alignment of the street. And now, you can say, yes, this is only chain. But this and this, second time the same chain, well, I'm very surprised, huh? So I cannot continue to develop the complete study of the city. I just explain the basic. Today we fully analyze 45 cities. 29 in Czech Republic, 6 in Slovakia, and 10 in Austria. So the cities in Czech Republic. And now, to be complete, I must say that we can distinguish families, sorts of cities, in function of the typical practices of the surveyor. This is what we call the D12S1. D12 means use of unit of angle of 90 degrees divided by 12. And S1, we use only one station to make the complete triangulation. So this is the D12S1. These two are D12S2, 2 stations. We have another family of cities we call the D16S4. D16 why? Because it's not the same unit of angle that was used there. Surprisingly, it's now 90 degrees divided by 16. And all these cities, 16, use 4 stations. 4 stations are always located at the 4 corners of the marketplace. The marketplaces here have 4 sides, always 4 sides. Rectangle, square or parallelogram. I forgot to say, in the D12S1, the marketplace have always more than 4 sides. They are polygonal and always more than 4 sides. Why? I don't know. We don't know. We just establish it. Last family is D12S4. I stop. So the use of 4 stations in division S4 and the ability. So now I finished, 20 minutes. But you must just understand that the quality of our study depends on the knowledge of the correct position of the walls. And we never know it exactly. That's why we need the help of archaeologists, of historians, or people who know the early beginning of the city. So we want a collaboration either to validate the theory, either to demolish it. But without your advice, we are unable to continue. Thank you very much.